video. Thanks. You have to try really hard to force JavaScript's compiler to throw an exception with the code that you write, unless you simply just typed in the code incorrectly. Now, I suppose some might consider the fact that JavaScript tries so hard to work with whatever crazy code you offer it as a positive thing, but personally, I wish that JavaScript's compiler would throw errors more often. I mean, you should never be able to do something as absurd as what I'm about to do here. Let me paste in a little code. I mean, this makes absolutely no sense. Here we're going to attempt to multiply 7 times undefined divided by Panama. Okay, what's the answer to that? Well, you know, it looks at it and says, well, I'm not really sure that that's going to come out to be a number, so I'm just going to return not a number. And we can check for that, not a number, and, you know, I guess we can account for that in our logic of our application, but kind of wish it would just throw an exception, but I guess that's not the way that JavaScript is made to work. I suppose it tries to do whatever it can because it, I guess, figures that perhaps people come from many different programming backgrounds, or that since it's a dynamic language, maybe it should be able to accommodate any of these crazy situations. But when JavaScript does encounter finally something that it cannot work with, we call that an error. We call that sometimes an exception, an exceptional situation, an exception, something it just can't work with. And the JavaScript runtime will simply quit at that point, throw up its hands and say, I can't do anything with this line of code. And if I can't do anything with this line of code, that means I can't do anything with any other lines of code. I quit. So it's when it does actually reach an exception, it completely bails out on any additional code that you might have written. All right. So when this happens and you can identify where in code these issues are likely to occur, you can and should build some safeguards to ensure that they never happen again. Like in this case, we might write several lines of code prior to attempting line number 1. We might do things like to ensure that if, for example, these values were contained in variables, we might try to make sure the variable was not undefined. We would try to make sure that the variable had a data type of number and not string or something else, right? So that we could do that calculation and expect a real number to be assigned to the variable A. Oh, if we were working with objects, we might want to make sure that the property actually existed on the object that was passed into our function. And so we would look and say, do you have a property with this name? Does it have a value? Okay, we can work with that. And so there are some safeguards that you can kind of build around your code to bolster it, to make it more resilient to the possibility that its inputs were bad and that it ultimately might throw or raise an exception. So other times, these things might be completely out of your control. You still need to write your code in a defensive manner. So for example, you might want to request data, maybe JSON data, from a web server that hosts a web API. And depending on what you're requesting and depending on whether the web server is functioning correctly in that moment, you may or may not receive the data that you're expecting. So this might cause your code to throw an exception. Well, here's another case where you should be able to kind of code defensively, account for the possibility that an exception could occur, because calling into another resource across the world is a highly risky proposition, and it could result in an exception. So an exception and an error, I use those terms kind of interchangeably. In my mind, they're the same thing. But whenever a problem arises, an exception is raised by JavaScript in some way, the information about that exception is boxed into one of these built-in natives that we learned about several videos ago that were created in the exception, capital E, exception function. And it will give you an opportunity to inspect that exception or that error object and look at, for example, the error message and be able to handle it gracefully. And we'll talk about that in this lesson. How you can safeguard your code. The code that you suspect or that you know would be prone to throwing exceptions. And you can do that by wrapping it in a construct in JavaScript called try-catch. So here, let me comment this out, and then I'm going to create some examples. Let's create one where I know I can create an exception. So here I'm going to create a function called before try-catch. So here we're just going to create one and not attempt to catch any issues that might be created. Now here I'm going to just say let this variable obj equal to undefined, and I'm going to act like obj is an object. So I'm going to just act like it should have a property on it. So I'm going to do console.log obj.b, all right, and I know that this obj does not have a property b. That should trigger an exception in JavaScript. It's one of the few cases where we can actually force it to happen. So if that happens correctly, as I suppose, then you should never be able to execute this line. So if the previous line of code throws an exception, you'll never see this, all right? And just want to point this out here. I'm going to have to escape this in my literal string, this single quote in the contraction YUL, because JavaScript, and in this case, Visual Studio Code, doesn't recognize it as an apostrophe. It recognizes it as the closing single quote for my literal string. So to escape that character and treat it like I mean to treat it, as an apostrophe, I'll use a backslash right in front of it. So now that little combination of characters will treat it as an escaped apostrophe instead of the closing single quote. All right, but at any rate, just an aside there. Line 7 should never get executed because I am expecting line number 6 to essentially throw an exception. So here's what we'll do. We'll just call before try catch, and we'll execute that. And you can see that cannot read property B of undefined. Perfect. All right. Now let's introduce a different function called after try catch to kind of show you how this works. I'm going to comment out the call to before try catch. Here, let's just grab all this and copy it all. But I'm going to first of all create a try. And I'm going to go ahead and just hit enter on my keyboard. I'm going to use the arrow keys to like create a try catch statement. All right, see that? And inside of the try, I'm going to attempt to perform these 3 lines of code. Now I don't have high hopes for 17 ever running. However, I suspect that what I can do is do something like this if we were to reach an exception in line number 16, which we will. So in this case, what I can do is say I caught an exception that was thrown by the JavaScript compiler. And I can even inspect that error object, and I know that it has a message property. So we'll do something like that. But the key here is that this will not break my application. My application can continue to execute. So I can go console.log. My application is still running. So even if we encounter an exception like I suspect we will in line number 16, we can catch the exception, handle it, do something, and then move on. So let's start with this, then we can move on and see if there's other things we can do here. Whoops, what am I doing wrong here? Oh, I need to actually now call my after try catch. So now let's try to run it. All right, I caught an exception, cannot read B, property B of undefined, but my application is still running. So it did not completely just shut down my application. Perfect. Now, what I can do is actually add another statement called finally, and this will run regardless of whether my try makes it successfully all the way through or whether the catch has been invoked. So I can just do console.log. This will happen no matter what. All right. And usually use a finally statement to clean up any resources that you no longer need. I'm not sure how useful that is in JavaScript personally, but you might find a use for it. All right. And so you can see that we have hit the catch, but then it also executed the finally statement before continuing on with the remainder of the application. So there's a pretty effective software development strategy of throwing custom exceptions from your functions with the intent that those exceptions are caught by the caller. So it's a form of communication. If it succeeds, then it should succeed quietly. But if it fails, your function would then throw an exception that would be handled by the caller, and it can decide what to do next. So I'm going to comment everything we've done so far out, and we're going to create one more example here. So let's do that, and I'll comment all this out too. And let's go here. Okay, so this time, let's go function, perform calculation, and this calculation will take and look at a object that will pass in, and we're going to say, hey, if that object obj dot has own property B, wait, if it doesn't have its own property. So I could do equals false like that, or I can do a shorthand version of this by just using the exclamation mark right before the expression. See that? That exclamation mark? It kind of makes it the negative. So if has own property returns false, then the entire expression will be true. This is if not has own property equal true, essentially. Then what we can do is actually throw a new error. All right. So here we'll just describe or give it the message we want to tell what the problem is. Object missing property. All right. Otherwise, if that turns out to be a truth that the object does have its own property, then we can continue with the calculation, and I might just return, the value 6 or something like that. Okay, whatever the calculation using obj dot property B. All right. So here we go. Now we're going to call into that function perform higher level function operation, and here let's do let obj let that value equals 0. All right. And then let's do a try around value equals perform calculation. And I'm passing in an object that's undefined, right? Because I didn't set it to anything in line 41. So I know it's going to throw an exception. Here, I'm going to catch it. I know it's going to come back to me as a boxed built-in native error. And print that out. And what I can do then is kind of to show how this would work is if value is equal to 0, I know that the perform calculation didn't work, so I can run my contingency. Perhaps I can do some retry logic, whatever I need to do to make my application handle this exception gracefully, and then continue with whatever logic makes sense after that. So let's see if this works. I think I got this right. Let's call perform higher level operation, and I'm not sure what to expect to see here, but I don't want to see any exceptions pop up, other than the one that I'm printing out and throwing here. So let's try that. All right. I think in this case, I'm going to need to do this. Let's see if that works. All right, try that again. All right, that worked perfectly. Okay, so in this case, created an object, passed it in, doesn't have property B, so we throw an error. Remember, this is a strategy for us to do some checking and then look to make sure that if an exception happens, we can handle it. If not, we grab the value back. But if the value is 0, then perhaps we need to, we hit an exception. Maybe there's some other flag we can use to see whether we're getting the value we thought. Perhaps in the catch, we can do some work. Maybe in the finally statement, it makes more sense to put it there. But at any rate, we can gracefully recover from the exception being thrown because that's kind of just our strategy that, hey, this function does not have what it needs. So you're calling into it, but you didn't give us what we needed. So you're going to have to write some logic to figure out what to do next. All right, that's all I'm trying to say there. So this is a good start to help you understand that you do have options when you think about how to safeguard your application against potential exceptions that could occur and shut down your code completely. Ideally, you could think of all the ways that your code could possibly fail and attempt to mitigate those potential issues up front. But after you've done a reasonable amount of work to perform gated checks like I demonstrated here in line number 33, 34, and 35, then you can ultimately wrap your code in a try-catch statement, try-catch finally, whatever works for you. And furthermore, you can throw custom errors from one function to another as a means of communicating failure and allowing the caller to implement some contingency like we looked at in line number 50 there. Maybe even some retry logic to ensure that ultimately the application is performing correctly and it can recover from any exceptional situations. All right, that's all we really wanted to say. All right, so we're doing great. Almost done. We'll see you in the next video. Thanks.